Okay. I think maybe this is a little, it's a somewhat unscripted, it's pretty unscripted, the panel discussion. So we have 5 panelists. Right next to me is Rumman Chowdhury, and she's the CEO of Humane Intelligence. Then we have Virginia Dignum, she's a professor for ethics at the University at Umeå in Sweden. We have Stuart Russell, professor, Berkeley University. And Stuart, I think you have been to all our in-person summits. And this is fantastic. I think we should have given him an applause here. And then we have Amir Banifatemi. Without Amir, we wouldn't be here today, because Amir is a co-founder of the Africa Global Summit. And I think we owe Amir, we owe you a big thank you for actually bringing this together. Also, and then we have Anja Kaspersen. She is a former colleague in the sense we've worked at the United Nations, and she has an incredible background in security and diplomacy, and you are extremely well spoken. And I'm not quite sure. Well, you're also working for IEEE, and you're representing the Carnegie Foundation. So this is somewhat unscripted. I'm going to throw out some questions, and then whoever would like to take the floor, please go ahead. So we're talking about how to move from the AI framework principles to implementation. So governments and companies and universities, civil society have been spending quite a number of years trying to figure out what kind of rules, what kind of policies would we need in the realm of AI. And over the last months or a couple of years, quite a number of frameworks are being put into law. The European AI Act, which seems to be now a done deal, has been in the works, I think, for 5 years. And the United States put out its executive order. China's been working a lot on it, and there are many other efforts that are taking place around AI governance. So I would like to emphasize our discussion on how we could actually measure, how could we actually implement the frameworks. So how would we actually know that what the policymakers have been deciding, that this is working? Who would like to step in on this? Virginia?
I can start. I don't think we know necessarily whether the frameworks and the regulations that are putting forward are right, but we also don't know that AI, we get it wrong all the time with AI. So we also cannot expect that the frameworks and the regulations that we put out will be perfect the first time. Mm-hmm. And I think that it's much more important to try and to test the different types of approaches. They are already, first thing is also that it is not true that AI is not regulated. Already now, without whatever regulations, AI falls under sector healthcare regulations, industrial regulations, product liability. So there is already a lot there, which makes that the AI that we use is as safe and as trustworthy as possible. In terms of the AI regulations and AI principles that we can put forward, we cannot know what is the best approach if we don't really, in the same way that we try with AI systems, we don't try and we don't put them forward. We don't have to wait until the law is perfect. If we wait until the law is perfect, we will be waiting forever.
I think when we have a scientific mindset, or maybe most of us, you just run an experiment, and if it doesn't work, you run another experiment. So I think we should just try it out, yeah.
Let me build on Virginia's point a little bit. Like I come from industry, and What I haven't heard is anybody ever sit the CEOs of the companies and say, is your product ready to be rolled out into the world? What if it's not working 100%? We are thrilled to see new products launch, right? And I think we can have the same safe, iterative approach to policy. And I completely agree with Virginia. One thing that I am, heartened to see here, one thing I want to note, I feel like there have been 2 conferences happening over the last few days. And there's one conference that is this room with the neon lights and the glitz and the glamour and the big screen and Nick Thompson from The Atlantic interviewing people about their opinions. There's another conference happening. It's mostly on the 3rd floor, I believe, and it's in different satellite offices. And those are people you will see, and there's no neon lights, there's no applause at the end of it, but they're putting their heads down and they're working together and they're solving problems. I'm really heartened to see that happening. And that's the room of people you should aspire to be in. You should be aspire to be in the room of problem solvers, because I will say, we know that policy won't be perfect, but we're gonna make it as good as we possibly can.
Okay. Stuart?
Yeah, so I want to agree with what's been said, but I think we are at the stage now where most of the policy that's been enunciated is at too high a level to actually tell, is my system in compliance or not? And so there's still a lot of work to do. If, for example, if you take an analogy to another area like food safety, you could have a high-level principle saying, food should be safe. People shouldn't get ill from eating the food. But then a huge amount of work was done to turn that into specific rules, like what temperature should cooked meats be stored at? How long can they be stored before they have to be thrown away? Exactly what has to be on the label? How often should we inspect restaurants? There are rules about how many rat hairs there are allowed to be in a can of beans, right? And the answer is, I think it's 1, right? So 1 is okay. I think you can have maybe 1 rat dropping for each so many kilograms of product and so on. So those have been worked out, and then you can tell. Someone can come along and look at the can of beans and count the rat hairs, right? We are nowhere close to that with AI systems. So we talk about fairness. There are dozens of definitions of fairness. The NIST risk management framework has basically an IOU. It says, look, there's all these definitions of fairness, and we still need to work out which ones should be applied to which kinds of decisions, and what degree of compliance has to be achieved, and so on. So as Rumman says, there should be people working on nailing down all of those details. And it's interesting, actually, one of the questions, so Reinhard sent us some questions to think about. One of them was, is AlphaFold safe? That's a really difficult question to answer. We think of AlphaFold as being very beneficial to science. I have lots of biology colleagues who love it. They're like kids in a candy store. But there are ways of misusing AlphaFold. And we've seen, for example, an analogous case where chemists were able to use one of these molecular design programs to actually synthesize new toxic weapon chemicals by the 1,000 in the space of a few hours. So AlphaFold is not safe in the sense that if someone says, okay, I want to use AlphaFold or some variant of this kind of analysis program to, yeah, you can go, but let me finish my sentence. AlphaFold is not set up to actually prevent that from happening. And so then the question is, what do you do about that?
Okay.
Well, I want to dig into this AlphaFold example because you yourself have touted the FDA as a great example of, how drugs are made safe. So I want to emphasize that making AI safe is not about just inspecting the model and beating up the model until we've created the appropriate safeguards only in the model. We have never done science that way. When we have made science safe, it's because we have created the appropriate infrastructure in the real world. So if we talk about, let's say, someone's ability to make some sort of toxic chemical, a bioweapon, they would actually have to have the ability to physically synthesize those chemicals, which actually in many cases is restricted. They would have to figure out how to distribute it and get it out there into the world, right? So there are many steps, many of which are human, to getting that to happen, right? So, I just want to make sure that, theoretically one could say that about pharmaceutical companies and getting drugs out there, right? They could cut corners, et cetera. But this is why we have these institutions of governance set up to ensure it's safe. So I don't want to get people overly worked up about, oh my God, we have to make sure these AI models can't create chemical bioweapons, because to be clear, the AI models themselves, if they are spitting out a formula or a way to do it, is not the end of creating a biological weapon. You can find the recipe for malicious weapon, biological weapons like anthrax, right, online. That doesn't mean we're all at a risk of being poisoned with anthrax. I just want to clarify that there is more than just governing a model.
If I just can go back to Stuart, just to finish the AlphaFold discussion. I mean, you're known to say AI models need to be provably safe. How would you put a provably safe stamp on a model like AlphaFold?
So actually, the point of my example is precisely that at the moment, deciding safe or unsafe is too difficult, and that we could, if we have a high-level principle, models should be safe, we can't turn that into a specific regulation. But what we can, what we can do is say here are completely unacceptable behaviors by models, and require that developers show that their systems will not exhibit those unacceptable behaviors. And those unacceptable behaviors are only small subsets of the totality of unsafe things that could happen. But for example, a model that replicates itself, that breaks into other computer systems and takes them over and makes copies of itself, we would consider that to be unacceptable. And therefore it would be reasonable that regulation should require a demonstration that the system will not do that.
I see that Virginia is super eager to jump in, but let me try to get Amir and Anja in. Would one of you like to talk about the AlphaFold discussion here? No? Or you would, okay, you don't. Okay, fine. So Amir, do you think we are on the right way with respect to implementing, or what is it that we have to do to implement the AI governance frameworks?
Well, my opinion goes back to the observation the past 8 years of AI for good deployment in general, where we have witnessed that machine learning and AI models, and recently LLMs-based approaches, have demonstrated significant progress on identifying patterns, prediction, and ways to mitigate risk. The issue is governance, I think, is on a multiple level. If we look at the UN system and the stakeholders aligned here, we talk about inclusivity, democratization, safety, access, privacy, and we look at the industrial part, we look at productivity, efficiency, safety from a different matter, but not necessarily risk. So there is not necessarily alignment in terms of language and how we look at this. And the support for deployment of AI for good or governance of it is critical. Junction is scaling. Having a pilot or demonstration of a model is one thing. Deploying it within an application in a specific use case is another one, where there is engineering involved. There is probably another series of set of public safety, privacy, awareness, transparency that has to be involved. It goes beyond the model. So the governance, I'm not sure today we are still aware of all the layers that have to be worked out. To Rumman perspective, when I think about product, there is a very clear guidelines about product deployment. When I think about research, we're still observing, and researchers are now fearing, but probably rightfully so, that there is huge risk ahead if we don't control those models. But probably we're not at the place where we can actually deploy them from an engineering perspective wide enough. So the question about governance is that who's in the governance room, and how this governance discussion should be taken care of, and what type of methodology or vocabulary are we using. But definitely, to paraphrase what Virginia is also saying, is that governance should be focusing on good AI, and let her amplify that concept, which we all arrived at, is that we're talking about AI for good, and the governance of AI for good should start with good AI. And what is good AI? And what is safe AI? What is AI that can be deployed? Not everything needs to be deployed necessarily, and that conversation about governance should continue with probably a line on vocabulary and concept that is measurable, and I'm emphasizing that scaling is the issue. We need to be able to think about how to scale for the public good at a large level, and this is where the governance should be emphasized first.
Anja?
I think we sometimes get caught up in making these binary propositions, good, bad, safe, unsafe, risk, benefits. Rumman made a comment about this on our first day on the AI Governance Day. And it's kind of leading us down a path which is not helping with putting governance efforts. So systems, and it's interesting because I've been involved in this with Reinhard and all the great people at ITU from the outset. And there has been a big transformation with this conference. Because initially when it was first organized, it was even a poor comprehension about what are the societal impacts. Does it really affect us? I'm just a small SME, I'm just a small company. Why would I have to care about these things? We see a completely different comprehension about the societal impacts. But we're also moving further away because there's more and more push. Narratives matter. So there's a greater push to try to take control of those narratives and put forward those binary propositions. I see another thing which is quite interesting. One is the mechanical side of AI. I feel that that's sometimes lacking. We had a lot of really deep dives into technical insights, sometimes maybe a bit isolated or insular from each other. But to understanding issues like systems integrity, once you embed any form of AI into a system, you actually change the entire integrity of what you're trying to do. And that's not often understood on the policy side. And this is critical when you're trying to think about putting governance in place. The other thing I see where we're still struggling is that of a shared language. You talked about language, the nomenclature. And we know how difficult it is to do within our own fields when it comes to actually putting effective governance frameworks in place, to even have a clear and shared idea, what are we trying to govern, at what state of the process? Like, for example, in the ethic, kind of embedding ethics and safety by design, in the early conference days, that was seen more as a sloganeering. Now I think it's understood that it has to be that way. But even that looks different from who you are in that equation. Are you a company that develops these systems? In which case the ethics starts at the conceptual development stage. But if you're a public sector or you're an organization, that ethical kind of hardcore work that needs to happen actually starts at the procurement stage. You have to know what you're buying, and you have to know that you even have the right problem you're trying to apply to. I'm sure Stuart had the same thing. The amount of conversations that we go to where the problem that is being described is not an AI problem. It's not even a governance problem. It's a human problem that needs to have completely different vectors inside. So my point is that narratives matter more than ever. Who gets to define these technologies, what they are, what they're used for, the words that are being used towards it, and the questions that are being asked. So always when I come here and when I speak, I always say, I hope I leave you with good questions. Because this is the one feedback I get from so many people. So interesting, I learned so much, really interesting insights. I still don't know what questions to ask.
Virginia, thank you, Anja. Virginia, you wanted to get back to Stuart, or?
Many things. I could. Anyway, I think I fully agree, narratives matter. And the first narrative that we need to get straight is that AI is not a technology. AI, as we are regulating it, as we are using it, as it is impacting us, is a social technical system. And as such, we need to regulate it from the perspective of the technology, but we cannot forget those that develop, deploy, manage, govern, use, and whatever else. So when we talk about making the models safe or unsafe, we can make them completely safe, like we can probably make a scissors, the model of the scissors is completely safe and provable and whatever, and still someone can use the scissors for doing all kinds of whatever they want. Even regulations that come from your microwave, which probably also can be provable correct, I don't know, come with instructions, don't dry your cat inside the microwave. So we really need to take AI and the regulations and the use of it from a perspective of social technical effort. And as such, we also need all of us, and we are here because we believe in AI for good, and we believe that AI can make a big contribution for achieving the sustainable development goals to really make the world a better place, otherwise probably we would not be here. But we really need to start asking ourselves, all of us that are building these systems for good, how good are we really committed and building these systems? Are we willing and able to be accountable for whenever these systems fail or don't do what we expect? Are we using the data? Do we know which data we use where we are training the systems that we are building? Do we believe that are we really taking all the steps that we know, even without the regulations or without the laws there? Are we doing it good? Because this whole issue of regulation starts with us, not with the models. It's with us. And if we don't trust the model, then the first thing and only thing we can do is don't put it out there.
Rumman, I have a question for you, and then you can maybe answer my question and also respond to Virginia. You have been involved in model evaluation. Are we at a point where we could think about standardizing model evaluation, even though the basic science of model evaluation, I guess, is still in flux?
You have asked my favorite question. I think it's because the science of model evaluations are in flux, we need to have the conversation about standardization. So there's two parts of this. Virginia is 100% correct in saying that this is a socio-technical problem. Stuart had mentioned the NIST RMF, and I agree, and that was like some of the feedback that NIST had received. It's like, okay, well, it seems like a blueprint, but what's the implementation? And I know folks here have been probably flying in or busy or getting their hotels, but on Tuesday, NIST announced something called ARIA. It is a socio-technical testing platform. This involves model evaluations, red teaming, and field testing. So this involves engaging real humans in interacting with AI systems and testing specific use cases to understand how these models will act in the real world in both malicious and natural use situations. So one effort that I am spearheading and leading as Humane Intelligence is creating a global community of practice around the science of evaluations. I think it is very needed to think through best practices and methods for how evaluations work. For example, if we say red teaming, I think folks in the room who are familiar with me and what I work on know I work on red teaming in particular, but we don't actually have a science of how red teaming should work. How many people is a sufficient number of people to red team? Who qualifies as an expert? How do you know you're done red teaming? You know, how can you test the robustness of your red teaming responses? None of these are answered questions. That doesn't mean we don't go do them. That means we have to go and do them to get this information. But it is helpful to have different evaluation bodies, safety institutes, globally engaged on the conversation, because we do want to make sure that whatever these approaches are interoperable, agreed upon, Why is that important? Because let's say, the Malaysian government does their evaluation of an AI system, they should be able to hand that over to the Singapore government, the US government, the UK government, and everyone starts off knowing exactly what the best practices were. This is how science works, right? Scientists engage in a common shared language of science. Absent that, we need to create that language for AI, generative AI evaluation, so we can have a shared conversation.
Stuart, I'd like to turn to you again. We organized an AI Governance Day on Wednesday. And one way maybe to structure the field of AI governance is AI needs data, AI needs algorithms, and AI needs computing power. So you could think that you need data governance. You look at whether the data are that people have access to data, that the data are good. You can think of algorithm governance. How do you ensure that that's related to data governance, that you don't get biased results. And then you could also think of compute governance. And so I think that was a term that for maybe many of the participants was new. So you are a professor of computer science, and it seems that compute governance is actually the area where it might be easiest to measure something. Because if someone is training a model, you need compute power a lot if you train a large language model. So you need water to cool things. So this is something you can actually measure, and this might be easier than to measure whether your data are integer or whether the algorithms are biased or the data are biased. So can you give a little bit of maybe background on compute governance, what it is that could be measured? Is that a useful thing?
So there is a number of proposals, and you can see numbers in the European AI Act in the US executive order, where they'll say, a system that uses above this amount of compute in the training process is subject to additional restrictions and reporting requirements and so on. I think the number is 10 to the 25 operations. But the details of exactly what is an operation, is it a bit operation, is it a byte operation, blah, 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 it doesn't matter that much. So you can measure those things quite precisely, but it's not clear to me that they actually mean anything. There is constant ongoing research to achieve the same level of capabilities from much less compute, partly because it's very expensive to run 10 to the 27 or 10 to the 28 operations. And so I think any such hard threshold is going to be outdated very quickly. And if you think about it, right, humans learn from far less data typically than the systems that we're training. I mean, their text intake is maybe 100,000 times more than any human has ever read. So if we actually can improve the algorithms, we will find that we don't need anything like as much training data as we're currently using, and we don't need anything like as much compute to produce something that might be superhuman. So I'm not actually in favor of this idea that as long as we know where the big compute is, we're good. Mm-hmm. But there is an aspect of this overall problem where compute governance could be very important, and that's in the complementary side of, so we've got regulations that might eventually say, here's what AI models have to do, here's what we mean by safe, here are the tests and requirements and all the rest, and all of the bona fide actors in the space will comply, we hope. But then what we call the Dr. Evil problem is that there will be actors who have no interest in complying with any kind of safety regulations. And how do you prevent the proliferation of extremely dangerous AI systems? systems that can replicate themselves, that can break into other computer systems, that can destabilize markets or hoodwink entire populations into misunderstanding the situation that they're in. And that's going to be, I think, controllable not through the kind of policing that we're currently trying to do with malware, which is a complete and total failure, but it's going to have to be at the level of the hardware itself, because software is produced by typing and can be copied and transmitted at the speed of light. It's very hard to police. But hardware is produced only by a very small number of manufacturers. If Dr. Evil wants to bypass the existing hardware ecosystem, Dr. Evil has to build their own TSMC, which requires hundreds of billions of dollars, tens of thousands of engineers, and decades of work. And so if you can get the hardware itself to check that the software objects that they're about to run are compliant and refuse to run non-compliant software, then you have a chance of preventing this, this problem. And you would also, as a byproduct, be able to get rid of malware as well. So there's a huge amount of technical work that needs to be done to make this possible. But the ideas, the technical ideas, go back to the 1990s with a technology called proof-carrying code, where the software object comes with a proof that the software actually complies. And that's something that we could then implement in hardware and get somewhere.
Yeah. Anja, I'd like to ask you a question, and then you can think about how to answer or how to comment on Stuart's response. Are we on the right way towards coming up with good rules, policies for our governance? Would it take, we talked a little bit before, would it take perhaps a major catastrophe? And I'm not quite sure how to define a major catastrophe. Would 100 people have to die? Would 100,000 people have to die, or something similar? Or would it be rather maybe a slow creeping process, AI taking somehow control, more and more control over our lives, like with, Regina said, like with climate change? Would it take a disaster, or would it be a creeping process? And then it might be too late, yeah? Like with climate change, maybe we're too late. Maybe we could have reacted earlier, but earlier scientists didn't really know how this all worked. So what's your assessment?
So I need to say I'm strictly taking all my official hats off when I answer that question, because this is purely my personal statement. I think we might see both. You know, when you look at the history of technology, especially when you look at it from an international security perspective, there are unfortunately trends when you have big transformative technologies to sense the urgency around regulation, around coming together. Often it does follow something that is undesirable happening first. But then you also have this creeping effect, you know, where it sort of penetrates more and more. What we do is making us almost spectators to ourselves. So it's also changing society at a very kind of granular level, where we may not have the resilience in place, both at the human level and at the society level. Now, I just wanted to follow up on something. So that's the question to you, kind of bigger issue. But I do think Stuart is making a really essential point, which is often seen as a bit more unsexy side of AI, which is all the people that need to work on these systems in the background, the people required to maintain them, to upkeep them. I remember the first time I met Stuart, you know, he was lecturing and he was saying, for everyone in the room, read Machine Stop. Do you remember this? It's a novel from 1905, 1904, 1905, 1909. And essentially how we become over-reliant on this big computational system and we stop checking in with ourselves. And there is a real risk of that at a human level. Now, going to the governance side, I just want to make this point. So one thing I do worry about, to the second part of your question, is that we're seeing an extreme level of fragmentation. This goes back to my issue of narratives. You know, how we speak about it, how we govern it, you know, regulatory frameworks that actually might be pushing us into very granular approaches to it rather than coming together. There's another component to it, which is we actually have a lot in international governance instruments today, including ITU, that can be brought together to create this framework. You know, anyone who works in computer science would know this concept of middleware. You know, the mechanisms you use to bring things together. So if we can emulate on some of the really critical experiences that we made internationally, you know, on issues of nuclear safeguards, etc. The Atomic Energy Agency is also here at the conference, which was really hard-won, difficult things to negotiate. But we have done it in the past, where you found that balance between promote and protect. So we need to be a little more unafraid to tap into what we know, to the experience that actually exists in the national space. And that's where standards come in. And the Secretary General spoke about it, I think, twice during this conference, the importance of standards. And of course, my organization is also involved in this space, especially the social technical space. And I see, because I come more from the policy side, I actually see standards. Standards does a very important job in building confidence between people that work in technical fields. But it has this untapped potential to also help building confidence or doing confidence building between policy makers. It offers that sense of, you know, the clarity on nomenclature. It offers guidelines or insights into the limitations of a system, to the opportunities, to the maturity of a system. So actually looking at standards also as a baseline of bringing greater convergence where we find ourselves very divided, I think is an untapped potential in that space as well.
Amir, you have the last word. What is your assessment with respect to AI governance? Are we on the right track? What would you like to see over the next year or so that should take place?
Well, after everything we said, I think we agreed on a number of topics about language and clarity and testing. I think the focus on AI governance should be on promoting what I said earlier is defining good AI and trying to implement as much as possible good AI in all the layers of SDGs to understand and gather data from the ground up. Of course, standard organizations have to work to create standards. They have to have ground truth data to work on those standards. We have to have measure and metrology. We have to be able to characterize those issues. If we don't experiment more, we're going to be staying at the level of conversation, which is pretty much a binary negative, as was suggested by Anja as well. The concept of good AI has to be defined. We're going from AI for good. We need to probably put an adjective of good AI in front of it. But I say we need to work on good AI for good.
Okay.
And good AI is a safe, trustworthy, human-centric, beneficial that provides value and make sure that researchers, scientists, those who are implementing and monitoring systems also align with this concept and try to implement it. And in that case, governance should also provide a framework about how should we push more good AI to our society. There is an issue of literacy as well. We usually drive cars and use knives and scissors and many objects that could be dangerous and lethal, but we have learned to understand their limits and their boundaries and what to do with them and not. Bringing up literacy at the global level, I think, should be an act of governance to make sure that everyone understands the limits and the limitations and find a way to make sense of what we're talking about. I think we still have a two-speed society going on right now.
Okay, that's a good closing word. Amir, good AI for good. So thanks a lot to the participants, including Virginia, who needed to catch a plane. Otherwise, she will be stuck here. Thanks a lot.